square root property. So we've talked about the zero product property, where we know that if I have factors and I have a product of 0, that one of those factors has to be equal to 0. That is one way we can solve quadratics or polynomials of any degree. Another way that we can solve these is the square root property. So the square root property can be used to solve equations with repeated factors. So again, when I think about my perfect square trinomial, I had a factor that was repeated. It was multiplied by itself. So the square root property for any number where n is greater than 0, if x squared equals n, then x is equal to the positive and negative square root of n. So I'm basically going to take the square root of each side and figure out what the square root is until we get that variable by itself, so it's not squared anymore. So let's see how this works. 16n squared plus 16n plus 4 is equal to 0. Again, at this point I'm still working with is equal to 0. But what I want to look for is that on one side I see a perfect square trinomial. But before we do that, take out greatest common factors, please. Please get in the habit again of doing that first. So I can factor out a 4 from all of these. So that leaves me with 4n squared plus 4n plus 1 equals 0. And so I'm going to go through my list. Do I have a greatest common factor? No. Before I start to look to see if I can find a product sum, I'm going to look for a perfect square trinomial. I want to look for that first because that's a really simple pattern to do. So 4n squared, yes, that's a square root. Has a perfect square, it's the square root of 2n. 1 is a perfect square, has a square root of 1. 1 times 2n is 2n, times 2 is 4n. So yes, this is a perfect square trinomial. So I can factor it so it looks like 2n plus 1 squared. Since I know this side with my variable is a perfect square, I can take the square root of both sides. So the square root of 2n plus 1 squared is 2n plus 1. The square root of 0 is 0. So I end up with 2n plus 1 equals 0. Subtract 1 from each side, 2n equals negative 1. Divide by 2, I get n equals 1/2. So I have one solution here. Even though we've talked about that this has a degree of 2 and there is at most 2 possible solutions, technically there are 2 solutions to this, but there's only one explicit solution. There's only one, it's the same thing twice, so I only have to list it once in this case. Because remember, we may have 2 solutions, we may have 1, and we may not have any solutions. All right, let's try another one. X squared plus 10x plus 25, again, equals 0. On my left-hand side, I do not see a greatest common factor there. I do see that it looks like ax squared plus bx plus c, so the first thing I'm going to check for is a perfect square trinomial. X squared is a perfect square, square root is x. 25 is a perfect square, square root is 5. 5 times x times 2 gives me 10x. That works. So I'm going to factor this into x plus 5 squared. Since I have a perfect square on one side, I'm going to find the square root of each side to isolate that variable. I get x plus 5 equals 0. Subtract 5 from both sides, I get x equals negative 5. So my solution is negative 5. All right, let's look at 2 more. I have x squared plus 4x plus 4 equals 64. Now notice this is equal to 64 and it's not equal to 0. We can still work with that if I notice that the side with my variable in it is a perfect square. So in this case, not setting it equal to 0 might actually make more sense. So I'm going to leave it this way, and I notice that this side is a perfect square trinomial. X squared is a perfect square, its square root is x. 4 is a perfect square, its square root is 2. 2 times x times 2 gives me 4x. That's my middle term, so I can factor this into x plus 2 squared. From here, I can take the square root of both sides. Now, because we're not working with 0 anymore, I want the positive and negative square root of 64, because it could have been a positive 8 before this, it could have been a negative 8 before this. I want both of them. So I end up with x plus 2 equals positive and negative 8. I'm going to split those up into 2 equations. So I end up with 6, x equals 6, and I also end up with x equals negative 10. So there are my 2 solutions that will work in this equation. Again, notice in this particular case, getting my equation equal to 0 didn't particularly help me. I was actually able to take advantage of the fact that I have a perfect square here. All right, my last one, I have y minus 3 squared equals 6. So this is already factored on the left-hand side, and I see that it's a perfect square. So I'm going to take the square root of each side. I see that I can just do that. So I'm going to take the square root of y minus 3 squared, which is y minus 3, but then I want the square root of 6, which isn't really friendly. So I'm going to leave it in what we call radical form. I'm going to leave it with this square root symbol here, the radical symbol. And I'm just going to put the plus and the minus in the front there. So now I'm going to work with it with that radical form. I'm not going to grab my calculator and write this as a rational or an irrational number as a long decimal. I'm going to leave it in the radical form to square root of 6 and work with it like that. So I add 3 to both sides, I get 3 plus the square root of 6. I add 3 to both sides, I get 3 minus the square root of 6. So I end up with two solutions here. One is 3 plus the square root of 6. The other is 3 minus the square root of 6. We like to get a little lazy because we've just done a lot of work. So you can totally write it as 3 plus or minus the square root of 6. Unless, if it's a word problem and we're talking about time or distance, then it makes sense to turn this into a real number. However, for what we're working with, where this is just kind of a naked equation where I don't really know what I'm talking about, it's going to make more sense to leave this in its exact form as that radical. So again, taking the square root of both sides of the equation, if I know that one of the sides, the side with my variable in it, is a perfect square.